Thing off the bottom. I'm sorry. I'm gonna try to work on it some more and see what I can figure out. The deal is that I got this set up to where there will still be probably a slight lag while I'm teaching, but if you go back and play the video, there's no lag at all. I do need a cookie. And I don't need it. Okay. So this is optimization. Let me let it focus. Okay, optimization, this is what number? Okay, and someone just tell me what 5 says. I should just grab the thing. Okay, so we're looking for d theta. If we were to draw a picture of this, here's x cubed, and I want to know as x moves on this, what is this triangle right here, this little theta? I know that's super tiny. How is it moving? So this is number 1. Number 2 is going to be what equation will relate x and theta and y, and what is it? Tan theta equals y over x. When I take the derivative of this, I get secant squared theta d theta dt equals this is quotient rule, so bottom times the derivative of the top minus the top times the derivative of the bottom all over the bottom square. Okay? Now, in order to find theta to plug it in here, I'm going to need to use the original relationship. So when x is 2, what is y? And what is theta? Well, I know that the tangent of theta is equal to 4. So what is the inverse tangent of 4? Does someone know this? From this relationship. Okay, actually, let's just leave it as theta is equal to inverse tan of 4. That way we're not reducing too early. So this is going to give me secant squared inverse tangent of 4, yes, equals 2 times dy dt. Okay, well, what is dy dt? X squared dx dt. So if you just take y and differentiate y, that'll give you so what is dy dt going to be? It's going to be 3 times 4 times 3. So 36. Okay, so back to here. Do you see where I got this, Jonathan? You're asking. Okay. Equals 2 times dy dt, which is 36, minus y, which is 8, times dx dt, which is 3, over x squared, which is 4. This should, and I don't even have d theta, which is what we're looking for. This should be times secant squared. So if you do this, let's see, what is it? 72 minus 24 is 48 divided by 4 is 12. So it's going to be 12 divided by secant squared of inverse tangent of 4. So if you have your calculator, go ahead and... Well, do it with inverse tangent to make sure you have the right... you did? And what is it? 75.9. Really? I don't, it's too high. Okay, good, because that scared me. That can't be right. Okay, so we said it was, what, 12 divided by secant squared, which is 1 over cosine of the inverse tangent. This is a nightmare to put in. Squared. 0.705. And that's going to be radians per second. That sounds much better. Or no, yeah, radians per second. Is that what y'all got? Is that 12 over 17? Okay. Yeah, you're right. Are you good with that one? Yeah, so you can see okay, number, what are we on, 6? You need to somehow mark where this starts. Okay. What does it say? Can you start over? I'm sorry. Okay, so there's number 1. What equation am I going to need? Surface area of a sphere, which is 4 pi r squared. So if we take the derivative of that, we get the derivative of the surface area with respect to time is going to be 8 pi r times dr dt. Okay, so the surface area, this is -1, 8 pi. Okay, what is the radius when the diameter is 10? Oh, wait, no. We have to go back because we did r and surface area, and we need to relate the diameter to the surface area. So surface area equals 4 pi times the diameter over 2 squared. Do you see?
Oh, wow. Yes.
Okay, so SA is equal to, this is going to be 4 on the bottom, so it's just going to be pi d squared. So SA, the derivative of the surface area, is equal to 2 pi d dt. And here we have -1 equals 2 pi times the diameter times d dt. So what is that? This, or it could be -1 over 20 pi, yeah. Whichever one. And what are the units? Centimeters per minute. What's the question actually asking? The rate at which it's changing, so it would just be positive. Okay?
So, it wouldn't have been okay if that were a diagonal now. Like a radius.
I think it,
Would that be negative 1 over 45? Why is there a difference?
because you would need to multiply it by 2. Or wait, what are you talking about?
Like, okay, you start on the left, and that's what I was going for on, but, and then so you're pointing 5.
Okay, this is the rate at which the radius is changing. If you multiply that by 2, you get the diameter. You could have done that, yes.
Oh.
Not divide. Okay. Okay, number 7. This is the one that Jonathan's on the board, yes? So just really quickly, since we're making the video, and that's why I don't have to explain it. On a video again. Here's the lights. Here's the man walking away from the lights. We're going to call this X, we're going to call this Y. We know that the guy is 6 foot tall, and we know that the whole side is 15. Alright, so similar triangles. Oh, by the way, I didn't write what we have. We know that dx dt is 5 meters per second. We're looking for we're looking for dy dt when x is equal to 40. Is that right? Okay. The equation that relates them is 15 is to x plus y as 6 is to y. Then we would say 15y equals 6x plus 6y, which makes, if we subtract 6, 9y equals 6x, and y equals 2/3 x. When you take the derivative of this, you get dy dt equals 2/3 dx dt. And we know that dx dt was 5. So dy dt equals 10 over 3 meters per second. And I think that's what the question is asking. And we'll say this is 4 and 5. Are we good on 7? Okay, and did you do 8? I think I told you to do 8, yeah? Did you do 9 too? I told you 8 and 9? Okay, 8. Someone read it to me. Okay, so I know that dx dt was how much? Miles per hour. That would be dy, yeah? Okay, we'll just change this to y. Sort of. And dx dt is 25 miles per hour. And we want to know what is d hypotenuse dt when what? After 2 hours. So since we don't have a variable of time, I mean, we have one, but not specifically in this in our drawing yet. So instead, why don't we just pick x and y? So what is x when the time is 2? It's 120. And what about y? Huh? 50. Okay, how am I going to relate these? Pythagorean's theorem, right? So we have x squared plus y squared equals h squared. The derivative is going to be 2x dx dt plus 2y dy dt equals 2h dh dt. Notice that the 2's, we can get rid of those since they all have a 2. Basically like dividing out 2 from everything. Okay, so then we would plug stuff in. This is step 4. X is 120. Dx dt is 25. Y is 50. Dy dt is 60. H is, I don't know. You can. What is H? 130. Is it 130 exactly? Okay. Great. Now I need your sign. It's okay. 130 times dh dt. And when we do this, what is dh dt? 65 miles per hour.
Oh. 65 miles per hour. 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 65 miles per hour.
What do you think about related rates? They're
Each one of
interesting.
the problems are worth
Okay, let's do 9. What does 9 say? I didn't draw a person very good. Okay, tell me one more time, read the problem.
Spotlight on the ground, on a wall, 12 meters long. If the man 2 meters tall, walks one spotlight toward the building, time speed is 1.6 meters per second. How fast is the length of the shadow on the building decreasing if it is 4 meters per second?
Okay, so the way I've drawn my picture here, we have the spotlight on the ground making the shadow on the wall. This is like a big tall wall. So Y is going to be the shadow. And then we have, I'm saying this is X as he's walking away from the light at 1.6. The whole distance here is 12, so this distance, it says when he's 4 meters from the wall, and my picture means when X is 8. And you could have drawn your picture differently and oriented it slightly different, and you would still get the same thing. So I'm just going to go with what I have. So I'm looking for dy dt when X is equal to 8. So what am I going to use to relate these? What did I say about shadow problems? Similar triangles. Okay, so I have 12 is to X. As Y is to 2, yeah. 12 is to this little one as the big one is to small one. Okay, here we go. 12 is to X, Y is to 2, right? Are we good?
12 is to Y as 12 minus X. 12 is to Y as X is 2.
This is 12 minus X, so this isn't in a similar triangle.
Oh, yeah.
So I'm saying the big base is to the little base as the big height is to the little height. Okay, which gives me 24 equals XY, and since I'm looking for dy, I'm just going to say that Y is equal to 24 over X. Step 3 is to take the derivative, so dy dt equals negative 24 over X squared dx dt. Right? Okay. So therefore dy dt equals negative 24 over 64 times dx dt, which is 1.6. So what does that give me? 0.6 meters per second. On step 4, maybe you would have negative, and then step 5, you should take it out. Very good. Why would I do that? No. Anyway. Okay, get your notes out. We're going to do maximum to minimum. By the way, our homework